have a question of multi-layer perceptron here. Assume that the neurons have a sigmoid activation function, perform a forward pass and backward pass on the network. Assume that actual output of y is equals to 0.5 and learning rate n is equals to 1. This portion is given for finding the backward pass, right? For forward pass, it is a very simple question, but on the backward pass, it is a little bit confusing. So this is a graph given to us. Here x1 and x2 are the input values. The input values of these two input layers are given. This h3 and h4 is the hidden layer. As you can see, h4 the hidden layer and o is the output layer. The actual output layer, the value of output layer is given as 0.5, right? So this will help in finding as forward pass as well as backward pass. So to find the forward pass, we will first calculate forward pass and then apply an activation function, which is given by yi is equals to faj is equals to 1 over 1 plus e minus power aj. So this is a very simple question for the forward pass, but for the backward pass, it is quite confusing. So to find out h3, why do we find the forward pass of h3? Because these input layers are moving in the forward direction to give the result of h3. And these two input layers also moving in the forward direction to give the layer of h4. Also, these two hidden layers are moving forward in the direction to give the output of O5. So we will find these three results for the forward pass. So to calculate the h3 of forward pass, if you don't know how to calculate h3 for forward pass, you can watch my previous video. I've explained it there. Also, I'm writing it here so you can see. So we will multiply x1 multiply by w13 plus x2 multiply by w23. So the value of x1 is given. The value of x1 is 0.35 and 13 is 0.1. So we will multiply 0.35 multiply by 0.1 plus the value of x2 given is 0.9 multiplied by w23 is 0.8. 0.035 plus 0.72, we will add to 0.755. Right, this is the value of hidden layer, but we will apply an activation function for that. The activation function for this is simple. So y3 is equals to 1 over 1 plus the result. This is the result. We will take its power in this e minus 0.755. How to perform this in a calculator, I will show you. It's so simple. 1 divided by 1 plus e. If you don't know the value of e, you can simply put the value of e from by pressing alpha and then this e, right? And then power of minus 0.755. So the result is 0.68. 0.68 is equals to y3. So you must be wondering, why are we calculating this y3? Because it is a forward pass. We calculating the forward values of forward pass, and it will also help us in the calculations when we are doing the backward propagation. Same we will do for h4 is equals to x1 multiplied by w14 plus x2 multiplied by w24, right? Putting the values. Now applying the activation function again for y4 is equals to 1 over 1 plus e power minus 0.68. Again solve the equation by using the calculator I described before, so the answer will be 0.66 for y4. Same perform for h5, O5. because it is the output layer and it moves in the forward direction. So y3 multiplied by w3 5. Hope you understand that. Why am I doing it? If you do not understand these calculations, you can also ask me in the comments, or you can watch my previous video. Okay, now we have to calculate the error. How do we calculate the error? There is a simple formula for finding the error. Error is equals to y of target minus y of 5. Because y of 5, why? Because y of 5, because y5 is equals to, this is the output layer, and we have to calculate the error rate for this. The y target for this equation will be 0.5, because it was given in the question. 0.5 minus y5 is 0.68, this y5. So 0.68, we minus this, and the answer will be 0.18.